YouTube bedtime science hook. Is the 3IATLAS real? Close your eyes and imagine a wanderer older than civilizations, a cosmic exile that has drifted through the dark between stars for billions of years, carrying secrets from a distant sun we will never see. Right now, as you settle into stillness, this ancient messenger called 3I/ATLAS is racing through our solar system at 130,000 miles per hour, its icy heart awakening as it tastes our sun's warmth for the first time since leaving its alien birthplace. Tonight, we follow this interstellar ghost on its lonely journey through the void and discover why some astronomers whisper that we may be witnessing the universe's most extraordinary delivery, a letter written in ice and starlight, addressed to no one, yet somehow finding its way to us. What if silence was the first sound of creation, and darkness the first canvas? In the earliest moments, before names or numbers existed, the universe unfolded in a rhythm older than memory. There was no up, no down, no center to orient thought, only a sudden bloom of possibility. In less than the blink of an eye, space itself stretched, an expansion so swift it outran even light, smoothing chaos into order. The emptiness was not void, but potential, brimming with the seeds of matter, energy, and time. In that stillness, the first sparks of wonder ignited, invisible yet destined to shine across eternity. From that expansion, particles emerged, ephemeral at first, flickering in and out of being. Quarks and leptons found balance, guided by the laws that would never break. Protons took shape, electrons found their orbits, and hydrogen was born as the simplest of elements, a whisper of structure in a sea of change. Hydrogen would become the canvas upon which the cosmos painted its grand story, waiting patiently until gravity's hand drew it into new forms. The first atoms drifted in vast clouds, silent as they expanded across an infant universe, carrying within them the promise of stars yet unborn. The fabric of existence, once a blur of energy, began to cool and settle. Forces that were once unified parted ways, becoming distinct, gravity to pull, electromagnetism to bind, and the nuclear forces to fuse or fracture. What appeared to be stillness was, in truth, delicate balance, each interaction setting boundaries for all that would follow. Gravity gathered hydrogen like a potter collecting clay, shaping invisible filaments that would stretch into the scaffolding of galaxies. The universe was no longer an endless firestorm. It had become structured, patterned, and capable of holding memory. In these structures, the first true flames were born. As hydrogen gathered, pressure mounted, and at last fusion lit the earliest stars. Their light pierced the cosmic dark, transforming emptiness into radiance. Within their cores, heavier elements were forged: helium, carbon, oxygen, seeds of future worlds, hidden in the furnace of stellar hearts. Galaxies spiraled. Outward, stars arranged in constellations of fire, and the night gained its first colors. What had begun in silence now glowed with music, not of sound but of light, a cosmic hymn resonating across billions of light years. Even now, that story remains written in the night sky. The faint afterglow of the beginning, the cosmic microwave background still lingers, a soft echo of the first fire stretched thin across the heavens. Every photon within it carries the memory of when the universe was only a few 100,000 years old, when matter and light first parted ways and the cosmos became transparent. It is a relic not of destruction, but of unfolding, a soft whisper that everything seen today is stitched from the quiet rhythm that began there. To look at the universe is to look into this memory, to see silence transformed into eternal illumination. And so, creation was not born in violence alone, but in harmony, in a balance between expansion and collapse, between stillness and motion. The first sparks of hydrogen, the first weave of cosmic filaments, the first stars igniting in the dark, all were part of a patterned unfolding. It was not chaos, but design born of natural law, a story both mathematical and poetic. In the calm of that realization lies a reminder: Wonder does not shout. It begins in silence, gathers its strength slowly, and then reveals itself in brilliance too vast to ignore. Every glance at the stars is a return to that beginning, a quiet remembering of how simplicity became eternity. Threads stretch across the cosmos, unseen yet binding. Gravity, patient and silent, is the loom on which the universe was woven. From the haze of atoms drifting in the early dark, it began to pull, to gather, to shape. Matter did not remain scattered, but aligned along invisible pathways, filaments of dark matter that guided the birth of galaxies. Expansion might have seemed aimless, but hidden within it was order, a geometry written into the fabric of space. These filaments span billions of light years, their scale too vast for any eye to hold. Along them, galaxies cluster like jewels on a string, glowing nodes connected by rivers of gravity. Between these strands lie immense voids, silent regions that define the contours of the web. It is not a random scatter of light, but a patterned net, stretched and shifting over time. Stars and galaxies drift upon these currents, their motion set long ago by threads that remain unseen yet ever present. Through telescopes and surveys, this hidden skeleton has been revealed. When countless galaxies are mapped, they form not chaos but coherence. Superclusters linking into chains, arcs of light tracing the pathways of matter. The foundation beneath it all is dark matter, outweighing the visible universe, shaping what cannot be seen directly. This shadowy presence is not emptiness, but structure, the frame on which the cosmos is built. Without it, galaxies would fly apart, and stars would never have held their place. Within the knots of these threads, gravity gathers hydrogen clouds into new suns. Filaments are not merely highways of motion, but places where creation pools and ignites. Each star carries the memory of these hidden paths, each galaxy a beacon along the lattice of darkness. The universe is not a lonely scattering, but a living network, where every light belongs to a greater web. Darkness itself becomes the stage upon which light exists. The cosmic web is scaffold, support, and silent architect, holding galaxies as though upon threads of silk. To gaze into the night sky is to see only the surface of a deeper weave, a design larger than vision, one that whispers of a universe not isolated but connected across eternity. Clouds of gas drift through galaxies like silent oceans, vast and unshaped. Within these cold expanses, gravity begins its patient gathering, pulling atoms closer until they lose the freedom of distance. Hydrogen, the simplest element, becomes crowded in the dark, pressed together until the very fabric of their particles feels the weight of collapse. Slowly, invisibly, the pressure mounts, and in that tightening embrace, something extraordinary stirs. A new star is being prepared. At first, the process is hidden. The cloud thickens, becoming opaque, its heart warming as gravity compresses it further. Deep within, atoms collide with such force that their individual boundaries blur. Temperatures soar to millions of degrees, and then the first fusion reactions spark. Hydrogen nuclei, once separate, merge to form helium, releasing radiant energy in the process. The transformation is profound. Matter is converted into light. In this ignition, the star draws its first breath. This breath is unlike any other. It is not the rush of air, but the balance of forces. Outward, the fire of fusion pushes with radiant energy, while inward, gravity continues to pull with relentless strength. If one side were stronger, the star would either collapse or scatter, but here, for billions of years, they reach equilibrium. This truce between expansion and compression defines the star's life, holding it steady, glowing in stillness and strength. Around these newborn suns, the nursery of creation glows with scattered light. Stellar winds clear away the remaining dust, carving out pockets in the cloud that allow their brilliance to spread. Some stars emerge gently, their light spilling softly into the void. Others flare violently, massive and short-lived, destined for dramatic ends. Yet all of them, regardless of size, share the same essence: the quiet rhythm of fusion, the pulse that transforms hydrogen into the elements of worlds to come. From afar, star-forming regions shimmer like ethereal veils, the Orion Nebula, The Eagle Nebula, the Carina Nebula, vast cradles where thousands of stars ignite within swirls of colour. These nurseries are both beautiful and transient, for once the stars mature, their winds disperse the clouds, leaving only clusters of light behind. The nebula fades, but its children endure, each carrying within them the story of their fiery awakening. The birth of a star is also the birth of possibility. Around some of these young suns, disks of gas and dust gather, slowly coalescing into planets, moons, and asteroids. The warmth of the star stabilizes these systems, providing energy, guiding climates, and setting rhythms that may one day nurture life. A single spark within a collapsing cloud becomes not only a star but a beacon that shapes entire worlds around it. And so, the universe fills with these quiet fires, each one a promise across ages. A star does not simply exist, it breathes in the balance of its forces, in the light it sends into the dark. From hydrogen clouds to shining constellations, its life is a testament to gravity's patience and fusion's brilliance. In every corner of the cosmos, the first breaths of stars continue, silent yet unending, weaving warmth and light into the fabric of eternity. Around newborn stars, faint disks of dust and ice begin to circle, fragile yet immense. They drift like rings of memory, delicate halos where fragments of matter gather and collide. Though silent, these disks are alive with motion. Each grain is a traveller, pulled by gravity, nudged by light, guided into paths that will one day form planets. The process is not quick but spans millions of years, as tiny particles cling together, building larger stones, rocks, and finally worlds. From the quiet chaos of dust, entire solar systems take shape. This dust is no ordinary substance. Each grain is a fragment of history, a survivor of stars that lived and died long before. Carbon atoms were born in the burning hearts of red giants. Oxygen was forged in stellar furnaces and scattered by supernova winds. Iron once lay imprisoned in the cores of massive stars before being cast outward into space. Every speck carries within it the memory of creation, the record of transformations that stretch across cosmic ages. Dust is not the beginning, but the continuation of stories written long before any planet was born. As these grains swirl, they begin to merge. Some collide softly, sticking together and growing. Others shatter upon impact, scattering fragments back into the disk, where gravity begins the process anew. Slowly, small clusters form, called planetesimals, building blocks of future worlds. These grow larger, pulling still more dust toward them, until they carve clear paths in the disk. In time, entire planets emerge, sculpted from what was once only drifting debris. The quiet persistence of dust, guided by gravity and motion, creates landscapes that will hold oceans, mountains, and perhaps life itself. Moons too are born from this dust, captured in orbits or coalescing alongside their parent worlds. Asteroids and comets remain as leftover fragments, frozen in time, carrying pristine samples of the early solar system. To study them is to peer back into the dawn of planetary history, to hold in one's hand matter unchanged since the beginning. In their icy cores, water waits, and in their carbon-rich material, the building blocks of life endure. Dust, though small, carries with it the seeds of entire futures. In every world, there is inheritance. Earth itself was built from ancient dust, from atoms that once resided in long-dead stars. The oxygen in seas and skies, the carbon in forests, the iron in human blood, all trace back to this cosmic ancestry. Planets are not isolated creations. They are mosaics of matter passed down across generations of stars. The dust remembers, and in remembering, it connects. To look at a planet is to see not just its present form, but the countless lives of stars that gave their substance for its birth. Thus, the architecture of solar systems is more than mechanics. It is memory inscribed in orbit. Around each young star, the dust swirls and settles, carrying the history of the cosmos into new beginnings. In silence, the smallest fragments write the grandest stories, turning the remnants of the past into the foundations of worlds yet to come. Across the cosmos, water gathers in places both familiar and strange, forming oceans without shores. On Earth, seas stretch between continents, shimmering under the light of the sun, but elsewhere, oceans hide beneath layers of ice, or simmer beneath thick skies of methane or ammonia. They are not bound to one world nor to one form. Wherever gravity and temperature allow, liquid gathers, and with it comes the possibility of stories unfolding in silence. These oceans are not just expanses of liquid. They are laboratories of chemistry, stages for forces that shape entire planets. Beneath the frozen shell of Europa, one of Jupiter's moons, lies a global ocean deeper than Earth's own. Tides stirred by the giant planet's pull keep it liquid, even in the absence of sunlight. Hydrothermal vents on its seafloor may release heat and minerals, providing conditions where chemistry becomes intricate, where complexity might bloom. Enceladus, a smaller moon of Saturn, sends icy plumes into space, hinting at an ocean hidden beneath its bright crust. Even there, in darkness, water moves and whispers of possibility. Not all oceans are water, as it is known on Earth. On Titan, Saturn's largest moon, lakes of liquid methane and ethane ripple beneath hazy orange skies. Though alien to human senses, they demonstrate that seas can take many forms, shaped by the chemistry of their worlds. Elsewhere, astronomers suspect super-Earths and distant exoplanets may host vast global oceans, endless surfaces without continents, where waves rise and fall beneath foreign suns. Oceans are not an exception in the universe. They may be a recurring theme, repeated across time and distance. These seas are more than liquid surfaces. They shape the very character of planets. They regulate climates, absorb energy, and distribute heat. On Earth, the oceans cradle life, carrying nutrients through currents that circle the globe. On alien worlds, oceans may play roles just as profound, creating stability where otherwise there would be extremes. Even where no life emerges, oceans sculpt landscapes, carve canyons, and leave chemical imprints that endure for ages. In their movement, they carry memory. To peer into the night sky is to imagine countless worlds where liquid flows unseen. Some oceans lie buried beneath miles of crust. Others stretch endlessly across surfaces without a single island to break the horizon. Each one is a reminder that water and liquid are not rare, but woven into the story of planets throughout the universe. They are mirrors of chemistry, reflections of balance, and symbols of potential. In silence, oceans hold secrets older than continents. They whisper of stability, of change, of cycles without end. They remind that worlds are not barren stones adrift in space, but dynamic places where even in the absence of light, motion continues. Oceans without shores are the quiet keepers of possibility, their depths carrying the weight of futures that may yet unfold beneath distant skies. A planet's atmosphere is more than air. It is a living veil, thin yet decisive. It shapes how light scatters, how heat is held, how rivers form or vanish. On Earth, this fragile sheath nurtures balance, oxygen to breathe, nitrogen to steady, carbon dioxide to warm just enough. It stretches only a few dozen kilometers before fading into space, yet within it, entire worlds unfold. Without an atmosphere, a planet is bare, exposed to radiation and silence. With one, it becomes dynamic, its skies alive with clouds, storms, and shifting winds. Each atmosphere tells the story of its planet. On Mars, the air is thin, incapable of holding warmth, leaving deserts where rivers once carved valleys. Winds still blow, sculpting dunes, but the pressure is so slight that liquid water cannot last on the surface. Venus, by contrast, wears a crushing shroud, clouds thick with carbon dioxide and sulfuric acid, trapping heat in a relentless greenhouse effect. Its surface burns at temperatures hotter than an oven, its skies swirling with storms hidden beneath opaque layers. Between these extremes, Earth rests in balance, its air clear enough to let sunlight through, dense enough to keep oceans liquid, and layered enough to shield fragile life below. The chemistry of atmospheres is both delicate and profound. A single element in excess can transform destiny. Too much carbon dioxide and warmth turns to furnace, too little, and the surface freezes in silence. Methane, ozone, nitrogen all contribute to the orchestra of climate. The interplay of these gases paints sunsets, drives seasons, and sets the rhythms of habitability. Every breath taken on Earth is the result of countless cycles: the respiration of forests, the evaporation of oceans, the movement of volcanic gases that together maintain the thin line between flourishing and extinction. Storms move within these veils like wandering voices. On Jupiter, bands of cloud form storms so vast they dwarf Earth, with the great red spot raging for centuries. On Titan, methane rains fall into alien lakes, echoing the water cycle of Earth in an unfamiliar chemistry. On our own planet, hurricanes, monsoons, and polar winds circulate heat, redistributing energy across continents. Each storm is more than weather. It is atmosphere in motion, a reminder that skies are never static but forever alive. To look upward from any world is to see more than emptiness. The sky is a mirror of the planet itself, its chemistry, its balance, its history. Atmospheres reveal whether a planet once held oceans, whether it still breathes with volcanic fire, or whether it is slowly fading into stillness. They are both shields and storytellers, fragile yet decisive. In their breath, worlds reveal their fates, whether they cradle life, scorch in silence, or drift barren beneath the stars. Beneath the calm surface of every world lies motion. A planet is never truly still. Its interior breathes in heat and pressure, shifting stone like water over spans of time too vast to witness. Mountains rise not in moments, but in centuries of uplift, pressed upward by the collision of drifting plates. Continents once joined drift apart like pieces of a puzzle, their edges still bearing the scars of ancient separations. Volcanoes, fed by molten layers beneath, exhale ash and fire into the skies, reshaping climates and painting new land from fire. These forces move slowly, but their patience sculpts entire epochs. The crust of Earth is a mosaic, cracked into plates that glide atop a mantle of churning rock. Driven by heat left over from planetary birth and the decay of radioactive elements, this mantle flows with an imperceptible rhythm, carrying continents across oceans, raising mountain chains, and opening rifts where seas will one day swell. The Himalayas rise where India presses into Asia, while the Atlantic widens where new crust emerges from hidden ridges. Over millions of years, these motions redraw maps, alter climates, and shift the paths of evolution itself. Volcanoes are voices of the deep. When magma breaks through, it releases gases that once lay locked within the mantle: carbon dioxide, sulfur, steam, shaping atmospheres as much as landscapes. Some eruptions are gentle, laying down fertile soil across valleys. Others are cataclysmic, clouding skies with ash that dims sunlight for years, altering global climates. Life, fragile on the surface, has been both nurtured and tested by these fiery outbursts. Yet without them, the recycling of elements would halt, and the crust itself would stiffen into silence. Time inscribes its stories into rock. Layers of sandstone, limestone, and shale are pages in an unbroken record, each preserving a moment when seas rose or retreated, when forests grew or burned, when glaciers advanced and withdrew. Fossils rest within them, testimonies of species that once thrived before vanishing into extinction. Floods, fires, impacts, all leave their marks. To read geology is to listen to the Earth's memory, a chronicle written not in words but in stone, stretching back billions of years. These silent architects of time remind that landscapes are never fixed. The mountain ranges admired today were once seabeds. The plains beneath feet may one day rise into peaks. Even the continents themselves are wanderers, destined to merge again into supercontinents before breaking apart anew. Species are brief compared to this rhythm, civilizations shorter still. Yet the rocks endure, carrying stories long after memory fades. The patience of geology teaches that creation is not always sudden or violent. Sometimes it is quiet, slow and deliberate, measured in layers that accumulate grain by grain. Mountains, volcanoes, drifting continents, they are not just features of a planet, but keepers of time. In their silence, they hold history longer than any living thing, whispering across eons that the Earth is always in motion, always becoming. Beneath the calm surface of every world lies motion. A planet is never truly still. Its interior breathes in heat and pressure, shifting stone like water over spans of time too vast to witness. Mountains rise not in moments, but in centuries of uplift, pressed upward by the collision of drifting plates. Continents, once joined, drift apart like pieces of a puzzle, their edges still bearing the scars of ancient separations. Volcanoes, fed by molten layers beneath, exhale ash and fire into the skies, reshaping climates and painting new land from fire. These forces move slowly, but their patience sculpts entire epochs. The crust of Earth is a mosaic, cracked into plates that glide atop a mantle of churning rock. Driven by heat left over from planetary birth and the decay of radioactive elements, this mantle flows with an imperceptible rhythm, carrying continents across oceans, raising mountain chains, and opening rifts where seas will one day swell. The Himalayas rise where India presses into Asia, while the Atlantic widens where new crust emerges from hidden ridges. Over millions of years, these motions redraw maps, alter climates, and shift the paths of evolution itself. Volcanoes are voices of the deep. When magma breaks through, it releases gases that once lay locked within the mantle: carbon dioxide, sulfur, steam, shaping atmospheres as much as landscapes. Some eruptions are gentle, laying down fertile soil across valleys. Others are cataclysmic, clouding skies with ash that dims sunlight for years, altering global climates. Life, fragile on the surface, has been both nurtured and tested by these fiery outbursts. Yet without them, the recycling of elements would halt, and the crust itself would stiffen into silence. Time inscribes its stories into rock. Layers of sandstone, limestone, and shale are pages in an unbroken record, each preserving a moment when seas rose or retreated, when forests grew or burned, when glaciers advanced and withdrew. Fossils rest within them, testimonies of species that once thrived before vanishing into extinction. Floods, fires, impacts, all leave their marks. To read geology is to listen to the Earth's memory, a chronicle written not in words but in stone, stretching back billions of years. These silent architects of time remind that landscapes are never fixed. The mountain ranges admired today were once seabeds. The plains beneath feet may one day rise into peaks. Even the continents themselves are wanderers, destined to merge again into supercontinents before breaking apart anew. Species are brief compared to this rhythm, civilizations shorter still, yet the rocks endure, carrying stories long after memory fades. The patience of geology teaches that creation is not always sudden or violent. Sometimes it is quiet, slow and deliberate, measured in layers that accumulate grain by grain. Mountains, volcanoes, drifting continents, they are not just features of a planet, but keepers of time. In their silence, they hold history longer than any living thing, whispering across eons that the Earth is always in motion, always becoming. Every star carries more than radiance, it carries influence. Its light pours outward, bathing planets in warmth and shaping the rhythm of skies, oceans, and winds. On Earth, this light nourishes the fragile process of photosynthesis, a quiet alchemy that transforms sunlight into food and breath. Forests, grasslands, and oceans all depend upon this steady flame. Yet the gift is delicate. Too close to the fire, and worlds burn. Too far, and they fall into silence and ice. Life, when it appears, is caught in this balance, a narrow band of possibility called the habitable zone. Within this zone, warmth is neither overwhelming nor absent. Here, oceans can remain liquid, and climates can shift between seasons without collapsing into extremes. The position of Earth within this temperate ring is no accident, but the outcome of orbital distance, atmospheric chemistry, and the gentle steadiness of the sun's output. Mars, resting just beyond, froze as its atmosphere thinned, while Venus, a little closer in, fell into a runaway greenhouse furnace. A planet's destiny can hinge upon the smallest variation in distance, the faintest tilt in balance. Shadows are as vital as light. On Earth, day and night divide the planet into cycles of growth and rest. Shadows cool the land, protect life from scorching heat, and preserve balance. Even in darkness, the fire of the sun leaves traces. Winds carry heat, oceans store energy, and ecosystems adapt to twilight and starlight. In this interplay, life learns resilience. Shadows remind that light cannot exist alone. It is contrast that makes balance possible. Beyond Earth, astronomers search for exoplanets within the habitable zones of distant stars. Some orbit red dwarfs, small suns whose light is dimmer, yet steady across billions of years. Others circle stars larger and brighter than the sun, where habitable zones lie farther out, like distant rings of warmth. For each, the question is the same. Does light strike with just enough strength to sustain seas, climates, and chemistry? Each discovery expands the sense that habitable zones are not unique, but scattered throughout the galaxy like hidden gardens waiting to be found. The fragility of this balance carries profound weight. A slight change in atmosphere, a fluctuation in stellar brightness, a tilt in a planet's orbit, all can push a world from comfort to desolation. Light is life's foundation, yet it is never guaranteed. The fire that sustains is the same fire that can destroy. Planets live between these extremes, their fates decided by how they hold the balance between warmth and shadow. And so, stars are more than distant points of light. They are sculptors of possibility. Their fire extends beyond brilliance, weaving the conditions for rivers, forests, and skies. Within their glow, worlds find their paths, and within their shadows, life discovers its strength. The cosmos is filled with these fragile rings of balance, where a single flame nourishes and a single misstep silences. In the quiet of their glow, stars remind that every shadow is cast by light, and every life rests upon the fire that endures. The search for other worlds begins not with vistas, but with whispers of light. Across the galaxy, exoplanets reveal themselves in the faintest signals, subtle dips in a star's brightness as a planet passes before it. To the human eye, these flickers are nearly imperceptible, but with patience and precision, astronomers read them as signatures of hidden companions. A tiny shadow crossing a distant star becomes proof of a world orbiting far beyond reach. These are not direct images, but echoes, hints that carry the weight of entire planets. The transit method, as it is called, allows astronomers to measure the size and orbit of these unseen spheres. When a planet crosses its star, a fraction of light is blocked, telling of its diameter. The timing between dips reveals its orbital period, its distance from the fire it circles. Some worlds complete orbits in a few days, hugging their stars tightly. Others take months or years, tracing wide paths that mirror the spacious orbits of planets in our own solar system. From these patterns alone, the architecture of alien systems emerges. Beyond transits, another technique listens to the pull of gravity itself. As planets orbit, they tug gently on their stars, causing tiny wobbles that shift starlight by the slightest of frequencies. This radial velocity method unveils the mass of a planet, revealing whether it is a gas giant, a rocky world, or something in between. Together, these methods weave portraits of unseen places, sizes, weights, distances, and rhythms. Though no continents or oceans are visible, the outlines of possibility grow sharper. Sometimes light carries more than shadow. As a planet passes in front of its star, starlight filters through its atmosphere, imprinting faint spectral lines upon it. These lines whisper of chemistry: hydrogen, methane, water vapor, carbon dioxide, molecules that shape climates and hint at conditions beneath the clouds. A faint trace of oxygen might suggest photosynthesis, while methane could hint at geological or even biological activity. Though fragile, these signatures transform echoes into sketches of skies, seas, and storms. Worlds revealed this way stretch imagination outward. Hot Jupiters, massive planets orbiting dangerously close to their stars, scorch beneath constant radiation. Super-Earths, larger than our own planet yet still rocky, may hold oceans without shores. Some worlds lie in habitable zones where liquid water might endure. Others orbit binary stars, living under twin suns that rise and set in shifting harmony. Each discovery is not just data, it is a window into landscapes unseen, a reminder that the galaxy is crowded with possibility. These echoes remind that little is needed to dream. A shadow, a spectral line, a wobble in starlight. Each holds the story of a world hidden in silence. They remain unreachable for now, far beyond the reach of spacecraft, yet their signals are enough to imagine oceans rippling under alien moons, clouds drifting across skies coloured by unfamiliar suns. In these faint signatures, the universe reveals that Earth is not alone in carrying worlds. The night sky is not just scattered stars, but a chorus of unseen planets, their echoes carried quietly in light. Light is the universe's oldest messenger. Born in the cores of stars, in the fires of galaxies, or in the afterglow of the Big Bang itself, each photon sets out on a journey through space. Unlike matter, it does not age in the same way. For light, time stands still as it crosses the void. Yet for those who receive it, every beam is history delivered to the present. To see is never to witness now, but always to glimpse the past carried across unimaginable distances. The stars scattered across the night sky shine as they once were, not as they are. The nearest starlight takes years to arrive. The farthest galaxies are seen as they were billions of years ago. Some of the stars visible above may already have burned out, their light still crossing the abyss long after their flames have died. In this way, the sky is a tapestry of memory, woven from countless strands of ancient radiance. Each point of light is both beauty and record, carrying the story of its source into the present moment. Telescopes extend vision deeper into this woven history. The Hubble Space Telescope, and now the James Webb Space Telescope, look so far that they capture galaxies formed when the universe was young. Their images are not snapshots of distant objects frozen in time, but of cosmic childhood, galaxies assembling, stars igniting, black holes stirring awake. Every photon reaching these instruments left its origin billions of years ago, travelling across an expanding universe to arrive just as lenses and mirrors were waiting. Even the faint glow between the stars, the cosmic microwave background, is light stretched thin by expansion, carrying the imprint of the universe when it was only a few 100,000 years old. This afterglow is not only a relic, but a map, showing the tiny variations that grew into galaxies and clusters. To study it is to look deeper into time than any history, to listen to the softest whisper of the universe's beginning, preserved in light that never ceased its journey. On Earth, light also shapes the rhythms of life. The rising and setting of the sun divides days, guides seasons and anchors biological cycles. Plants transform its photons into food, building the foundation of ecosystems. Shadows mark the passing hours, and colours at dusk or dawn remind that light is not only function but poetry. In its patterns, life has evolved, civilizations have measured time, and wonder has been sustained. The act of seeing is always a step backward in time. To gaze at a star is to look across years or centuries. To gaze at a galaxy is to look across millennia, or eons. In every beam of light is a record, proof that the universe is both ancient and ongoing. Light does not merely illuminate, it connects past to present, weaving time into vision. Each glance into the sky is an encounter with memory, a reminder that the universe reveals itself not as it is, but as it once was, carried to us in silence by the patience of light. Gravity is the quiet choreographer of the cosmos. It does not shout, yet its influence extends across galaxies, weaving order into motion. From the smallest moon to the most massive cluster of stars, every body in space follows its steps. Moons circle planets, planets trace arcs around stars, and stars themselves sweep through the arms of galaxies. This rhythm is not chaos but choreography, a grand celestial ballet where each orbit, each resonance, adds to the harmony of the whole. The predictability of gravity's dance is both delicate and profound. The moon pulls gently on Earth's oceans, lifting tides that rise and fall with the turning of the planet. Planets influence one another as they orbit the sun, their interactions creating resonances that can stabilize or disrupt their paths. The motions of comets, asteroids, and even the faint drift of spacecraft are written by the same law. Though invisible, the pattern repeats with such reliability that eclipses can be forecast centuries ahead, their shadows sweeping across Earth with clockwork precision. This dance extends far beyond familiar skies. Jupiter, with its immense pull, acts as guardian of the solar system, deflecting comets that might otherwise strike Earth. Saturn's moons, locked in resonances, keep its rings sharp and sculpted. Binary stars whirl about, each other in delicate spirals, their motions so precise they reveal the presence of unseen companions, sometimes black holes, sometimes planets hidden in their light. Across every scale, gravity is both tether and music, keeping systems bound while allowing motion to flow endlessly. Galaxies, too, move to gravity's rhythm. Stars orbit their galactic centers, tracing paths shaped not only by visible matter, but by the mysterious presence of dark matter. Clusters of galaxies are drawn together into even larger structures, tugged into filaments that span billions of light years. Though the steps are vast and slow, they are part of the same choreography that lifts tides on Earth. From ripples in oceans to the swirl of galaxies, the law is one, unbroken across scales. Even silence carries the mark of gravity. When massive objects accelerate, they send ripples through space-time itself, gravitational waves that travel at the speed of light. Detectors on Earth have recorded these faint vibrations, the echoes of black holes merging far away. In them is a deeper rhythm, a reminder that gravity's music is not only orbital motion but the very bending of space and time. To see the universe as a dance is to recognize the harmony within complexity. Orbits may shift, tides may change, galaxies may drift, yet all are bound by the same unseen force. Gravity ties the cosmos together, ensuring that silence is never stillness, that even in the emptiest void the choreography continues. The universe is not scattered chaos but a symphony of motion, where every moon, planet, star, and galaxy contributes to the eternal dance of gravity. Every star carries within it a clock. From the moment fusion begins in its core, the countdown to its ending is set, though measured not in years but in millions or billions. Stars are born in brilliance, but even their fires cannot burn forever. Hydrogen dwindles, fusion slows, and the balance between pressure and gravity begins to falter. The quiet death of a star is not a sudden extinguishing, but a gradual transformation, an evolution shaped by mass, temperature, and time. For stars like the Sun, the ending is gentle yet profound. As fuel runs low, their cores contract and their outer layers swell outward into red giants, enormous and luminous. In this expanded phase, they shed shells of gas into space, creating shimmering planetary nebulae. At the center remains a white dwarf, a dense ember no larger than Earth, glowing with residual heat. Though no longer burning, it will shine faintly for billions of years, slowly cooling until it fades into darkness. In its stillness, it is not gone. It is memory crystallized into matter. Heavier stars end more violently. With greater mass, their cores collapse under gravity's crushing hand, igniting layers of fusion in a desperate sequence until iron forms. At this point, no more energy can be drawn from fusion, and collapse becomes inevitable. The outer layers rebound in a supernova, an explosion that outshines entire galaxies for brief weeks. In the chaos, elements forged in the star's heart, carbon, oxygen, gold, uranium, are hurled into space, seeding future worlds. What began as destruction becomes creation, as new stars and planets inherit the fragments of the dead. Some remnants are stranger still. If the collapsing core is heavy enough, protons and electrons are pressed into neutrons, forming a neutron star no wider than a city yet more massive than the Sun. These objects spin rapidly, sending beams of radiation into the cosmos like cosmic lighthouses. If heavier still, collapse does not stop at neutrons. Space and time fold inward, and a black hole is born, its boundary a horizon from which nothing escapes. Such remnants are not endings, but transformations into new states of being, each altering the galaxy in ways subtle and profound. Through these cycles, nothing is truly lost. Matter is recycled, energy redistributed, elements scattered into clouds that will birth new generations of stars. The carbon in breath, the calcium in bones, the iron in blood, all once belonged to stars that ended long ago. Death in the cosmos is continuation, a passage from one form to another. Even the silence that follows brilliance carries echoes of what once was and what may yet come again. The quiet death of stars reminds that endings are beginnings disguised in silence. A nebula glowing in the night is the farewell of one star and the cradle of others. Supernovae scatter light, but leave futures seeded in their ash. Black holes erase light, yet shape galaxies through their gravity. In this endless cycle, stars teach that nothing is wasted, and even in death the universe continues to create. At the heart of mystery lies the black hole, not an object but a boundary. It is the place where gravity gathers such strength that even light cannot find escape. The horizon it forms is not a surface, but a limit, a line beyond which time and space themselves fold inward. To approach it is to encounter extremes, where the familiar rules of physics bend, and where certainty dissolves into silence. A black hole is both presence and absence, a reminder that even the cosmos carries secrets beyond direct sight. The journey towards such a horizon begins with collapse. When a massive star exhausts its fuel, gravity overwhelms its defenses, compressing matter into densities unimaginable. The collapse does not stop, for no known force can resist it, and the result is a singularity, an infinitesimal point where mass is concentrated and equations falter. Around it forms the event horizon, the invisible boundary from which no signal, no photon can return. From a distance, the black hole reveals itself not by light but by influence. Stars spiraling around emptiness, gas heated to brilliance before it vanishes, space itself curving inward. Yet black holes are not emptiness. They are engines shaping the very galaxies they inhabit. In their accretion, disks, rings of matter spiraling inward, particles collide at near-light speeds, releasing torrents of radiation. From some, jets erupt, beams of energy stretching across thousands of light years, regulating the birth of stars within their host galaxies. Far from being silent voids, black holes are dynamic, their presence steering the structure and fate of cosmic realms. They are sculptors hidden within shadows, unseen yet essential to creation. Time itself behaves differently near their horizons. To an outside observer, anything falling toward a black hole slows, its clock stretched by gravity's pull, appearing frozen at the edge. To the one falling, time continues, carrying them across the boundary in a descent no signal can recount. This duality, two truths held at once, is part of the strangeness that black holes embody. They blur the line between perception and reality, between what can be known and what can only be imagined. Even as they consume, black holes radiate. Through a subtle effect predicted by Stephen Hawking, they emit faint particles at their horizons, a whisper of energy that over vast timescales may cause them to fade. In this paradox lies the reminder that nothing is eternal, not even these titans of gravity. They too belong to the cycles of the universe, vanishing eventually into silence, leaving behind only the structures they shaped. To drift into the thought of black holes is to step into quiet awe. They are paradoxes made real, destroyers that create, boundaries that define, voids that sculpt galaxies. They are the dark horizon where knowledge meets its edge, where mathematics still struggles to describe the infinite. In their presence, the universe speaks softly of limits, of mysteries yet unsolved, and of the beauty that emerges when light itself bows to the gravity of the unknown. The universe that can be seen, stars, planets, glowing nebulae, accounts for only a fraction of what exists. Beyond the brilliance of galaxies lies a vast hidden framework, a structure woven from matter that does not shine, cannot be touched, and yet holds everything in place. This unseen substance, called dark matter, outweighs the familiar atoms of stars and worlds by more than 5 to 1. It is not visible in telescopes, yet its influence is undeniable. Like scaffolding beneath a grand cathedral, it supports the luminous architecture of galaxies, giving form to what would otherwise collapse or drift apart. The presence of dark matter is revealed in motion. Stars orbiting the edges of galaxies move too quickly to be held by visible mass alone, yet they remain bound, their paths anchored by an unseen halo. Light itself bends around clusters of galaxies, distorted into arcs and rings through gravitational lensing, showing where invisible matter lies in abundance. Though it cannot be directly observed, dark matter leaves footprints across the cosmos, reminding that the universe is more than what meets the eye. If dark matter shapes structure, dark energy shapes destiny. It is the force that drives the expansion of the universe, discovered not through sight but through acceleration. Distant supernovae shine fainter than expected, revealing that the cosmos is not slowing in its growth but speeding outward, as though pushed by a hidden hand. Dark energy dominates even more than dark matter, making up nearly 70% of everything. It does not gather into halos or filaments, but stretches space itself, a silent expansion written into the future of the cosmos. Together, dark matter and dark energy compose the great web of the invisible. They define the large-scale geometry of the universe, determine how galaxies form, and set the trajectory of cosmic time. And yet, their nature remains unknown. Are they particles waiting to be discovered, fields permeating space, or hints of laws yet to be understood? For now, they remain mysteries, detectable only by the ways they move and shape the visible world. The humility of not knowing becomes part of their beauty. Science measures, infers, and predicts, but the essence of dark matter and dark energy is still hidden. They are reminders that human understanding is partial, that the cosmos retains secrets even as it reveals wonders. Invisibility does not mean absence. Silence does not mean emptiness. The universe is filled with presences that lie beyond the reach of current instruments, waiting with patience for discovery. In reflecting on this invisible web, awe grows stronger. To realize that stars, planets, and life are built upon what cannot be seen is to feel both small and connected. The cosmos is not just light, but shadow, not just matter, but mystery. In this interplay, the universe speaks softly of limits and possibilities, inviting wonder at how much remains unseen and how much more there is still to learn. The cosmos is not only a stage of events, but also a keeper of memory. Every particle, every beam of light carries within it a trace of where it has been. Photons that left galaxies billions of years ago still stream across the void, bringing with them a portrait of the past. To look into the night sky is to witness history preserved in motion, light holding memory far longer than any living being could. In its endless travel, light becomes both messenger and archive, reminding that nothing vanishes without leaving a record. Rocks, too, are storytellers. Layer upon layer, they preserve floods, eruptions, and extinctions. Strata form a library of time, storing the memory of ancient seas, shifting climates, and vanished forests. Fossils embedded within these rocks carry echoes of lives long gone. Shells and bones transformed into stone, yet still recognizable across eons. Each layer is a page, each fossil a word, together composing the chronicles of Earth's deep time. Planets, like stars, keep memory not in voices but in landscapes that endure longer than civilizations. Atoms themselves are carriers of continuity. The carbon that builds a tree, the oxygen that fills a lung, the iron that strengthens blood, all were forged in ancient stars that died long before Earth was born. These atoms have travelled through countless forms, drifting as dust in nebulae, locked in stone, dissolved in oceans, breathed by creatures and released again. The body itself is a collection of borrowed elements, recycled matter stitched from the memory of stars. Existence is not new creation, but transformation, atoms passed down as inheritance from the cosmos. Galaxies too hold memory, not only in light but in structure. Their spiral arms trace billions of years of stellar births and deaths, while black holes at their centers store the imprints of collisions and mergers. The universe itself carries memory of its earliest moments in the faint glow of the cosmic microwave background, a relic of when the cosmos was young, still transparent for the first time. These echoes stretch across time, gentle reminders that the universe remembers even its own beginning. Memory ensures that nothing fully disappears. Energy shifts, matter transforms, life emerges and fades, but the record persists in altered form. A star that dies leaves elements behind. An ocean that recedes leaves shells in stone. A creature that breathes passes atoms into the air. Existence is stitched together not by permanence but by continuity, each moment carried into the next. Nothing is erased, only rewritten. In this way, the cosmos is a vast memory itself, a tapestry of transformation where past and present flow together. To reflect on this is to see unity across scales, galaxies, planets, oceans, rocks, atoms, all preserving stories of what has been. Memory does not cling to form but to essence, ensuring that even in silence the past lives within the present, and the present becomes the seed of futures still unfolding. Now and then, the solar system receives visitors not born beneath the sun. They arrive silently, slipping across the boundaries of interstellar space, carrying with them the memory of distant origins. One such traveller was named 3I/TLAS, the third confirmed interstellar object observed passing through. It was faint, fragile and fleeting, a comet whose path revealed it did not belong to our celestial family. Its orbit was not bound, it came from elsewhere, and it would return there, never to circle back. 3I Atlas reminded astronomers of earlier visitors, Oumuamua, elongated and enigmatic, and 2I Borisov, a comet whose icy tail resembled those seen closer to home. Unlike them, ATLAS broke apart before it could be studied in detail. Yet its very presence was proof of abundance. If 3 such travellers could be spotted within a short span of years, how many more must cross the galaxy unseen? The void between stars, once imagined empty, is now understood as alive with wanderers, fragments of other systems drifting endlessly across the dark. Though its structure could not be fully resolved, 3I/ATLAS stirred questions as profound as its predecessors. Was it a shard torn from a cometary cloud around another star, cast adrift by gravitational encounters? Or was it once part of a planetesimal disk, ejected during the violent youth of its home system? Its faint glow and fragile form carried no clear answers, but even fragments teach. Every interstellar comet is a messenger, bearing chemistry forged under suns far away, a chance glimpse into processes otherwise hidden across light years. The mystery deepens in absence. Unlike planets or stars which endure in predictable orbits, these visitors appear suddenly and vanish quickly, leaving only traces of light upon detectors. They invite speculation, not of science abandoned to wonder, but of wonder fueling science. Could the icy shells of such objects carry molecules essential to life? Could they, in scattering across space, have once seeded worlds with the raw materials for chemistry? Each unknown becomes not an ending, but an opening, a question stretching further than certainty. In this way, 3I/ATLAS becomes more than a comet. It becomes a symbol of openness, a reminder that discovery does not always provide closure. Sometimes it only widens the horizon, showing that the cosmos is larger, more intricate, more full of possibility than expected. Even a fragile visitor breaking apart before it could be fully known holds meaning. It proves that systems beyond the sun are not sealed worlds, but participants in a grand exchange, casting fragments into the currents of interstellar space. The story closes here, but not with answers. It closes with an invitation to wonder, to imagine, to recognize that even in the smallest fragment of dust or ice lies connection to something vast. The cosmos does not reveal itself all at once. It offers glimpses, echoes, visitors, and mysteries. 3i Atlas is part of that unfolding, a reminder that we too are wanderers, fragments of a larger story written in stars, dust, and silence, still being told across eternity.